It's all yours.
Lovely. So do you mind if I just close this? So hello everybody. Yeah, my name is Deborah Harvey, and today I'm going to talk about monitoring endangered species of beetle using pheromones. It's a bit of a condensed title because they're not all endangered, but they are all beetles. Then they're all the saproxylic beetles. I'm sure that some of the people that have said they are experts, I know at least Stuart Warrington and some of the others on here who've said have said that they're experts have actually helped me in the past, and I'm going to talk about what we've done and how we've done it. So you can see here on the right of the slide, we've got 4 pictures of beetles I'll be talking about today. We've got at the top here on the left, we've got the noble chafer. Bottom left, we've got the rusty red click. At the top right, we've got the violet click beetle, and at the bottom right, we've got my absolute favourite, the stag beetle. So my work has been on saproxylic beetles, and for those of you that are not sure what these are beetles that feed on deadwood during at least part of their life cycle. Using the larval stage, they stay within deadwood, or they can be larvae that feed on the species that feed on deadwood. Many of them are endangered across most of Europe. They have conservation status across Europe, from maybe least concern up to endangered. But they have a vital role as decomposers, pollinators, and as a food source for birds and the like. So, when can you monitor these? Well, one point that you can monitor them is as larvae, and that can be quite fraught, but I think it's probably one of the most important stages to monitor these species. That's a noble chafer larva up there, and I should talk about that later. Or you can do the adults. The adults are great for monitoring because you can get their pheromones and usually you can use either sex pheromones and aggregation pheromones. And when I talk about the work that I've done, I'll be talking about the 2 that we've used. Or you can do indirect monitoring using something like the frass that's produced by the larvae, in other words, the poo. That again has advantages and disadvantages. And again, as we go through, I'll tell you some about those. So the 3 beetles that I've actually been involved in running monitoring schemes are the stag beetle. Mainly an urban beetle in this country, lives mainly in people's gardens, which again presents some problems for monitoring. The rusty red click, this beautiful, about 2 centimetre long, tomato sauce red beetle, and this lovely iridescent noble chafer beetle that tends to live in traditional orchards in this country, predominantly pear. So how can you get the pheromones? Well, I suppose I'm not monitoring with pheromones, I'm monitoring with chemicals that have been produced after we've identified what the pheromones are and what they are. So there are 2 ways you can do this. The first way is you get your beetle, you kill it, you take the glands, and when you've got the glands, you take the contents of the glands out, and then you use that to develop a lure. I don't really like killing the beetles, especially the ones that are really, really low in numbers, because it feels like there are so few of them anyway, that why would you want to kill them? So I have gone down the route of doing this non-invasively. And how you can do this is you can do it using headspace analysis, and that's literally you put a beetle or some beetles into a glass jar, and then you put this device on the left where it says using SPEME. You put this fibre into the jar, and SPEME means solid phase micro extraction. And at the bottom of this, you can see there's a tiny thin fibre. That fibre is about the size of a piece of cotton. You put it into the jar with the beetles, and you leave it there for anything up to about an hour. And as they produce their pheromones, then they will collect on that fibre, and then you can use gas chromatography, mass spectrometry to identify the chemicals. The other way that you can do it is by air entrainment. This is easier for larvae, definitely, but we have used it for very small beetles. We've used it for the rusty red click. And in here, then you can take it for longer. So that's a very small container, but you can get a large container. You can put some kitchen towel, paper towel in there so the beetles have got something to hide on. And then you collect onto a carbon mesh the volatiles that they produce as you pull air through that. So you've got your compound, and you've either on your fibre or on your carbon, and you identify it. You hopefully, if it all goes to plan, you put it into the gas chromatography mass spectrometry machine, and you find it, and you find the compound, and you identify it, and then you buy it. Unfortunately, for most of these, they're not produced readily available, so then we have to synthesize it. And then the other problem is, of course, that when you do something like this, what you don't know is if the chemicals that are being given off are sort of pheromones that are being produced because they're frightened, in inverted commas, and so we're getting alarm pheromones. So before you put these chemicals out, you have to decide how much lure you need, how much of that chemical you're going to need, and you need to work out whether it is as attractive as you think it is, or whether it is a compound that is keeping away, say, an alarm pheromone. So when you use something like a olfactometer, here there's a Y-shaped one here, and you put the beetle down in the bottom, and you put one side, you put your pheromone, one side you put nothing, and you see if the beetle will go for it. And then you turn it around and do it the other side, and you blow air through it, you do it loads of times, and you see if it's the attractant compound that you think it is. So we've got that far, and we've worked it out, and now we can start trapping. So you get your traps sent out, and you start to monitor. This is, I think, probably for me, this is the most difficult bit, but this is the bit I enjoy the most, because here, now I start to call on volunteers, and I will be asking at the end of this talk for people to join me to do this. And I am so grateful to the people that are on this talk who have joined me and have helped me as volunteers over the summer months with a trap. Either this one I made, you can see this one is a very sophisticated one that I made out of damp coarse plastic, and an ice cream tub and a salad tub, so that I could post them with some green sticks from B&Q. And the beetle is attracted to the pheromone, which is put in a little vial at the top, it flies into the veins, falls down into the bottom, and you catch it. When people do this for me, there are often questions they ask: does it kill the beetle? Not if you're careful. It does kill beetles if people put out traps and just leave them and don't go back to them, because obviously these beetles are living things, and they can't be kept in a really hot tub with no source of nectar, nothing, for days. So whenever we do this, I always ask people to check their traps once a day, and if it's very warm, twice a day, or take the trap down. The other thing I always do is put some paper towel on the bottom, or put a nectarine source in, so that you can, at least you've made sure that you're doing the best that you can to keep the beetles safe. So does it kill beetles? No, if you're not careful. Does it stop mating behavior? No. We found beetles sometimes mating in the traps, but because they're checked so regularly, no, it doesn't, because you let them out before they, before they're held, because obviously we're not trying to stop them mating, we're trying to boost knowledge about them, not kill them all off. And the other thing is, people say to me, oh, beetles trap happy, and you keep getting the same ones to come back. No, you don't. We monitor the beetles. When we're doing this, we mark the beetles with I use a Sharpie, because Sharpies are brilliant. I know some people use Tipp-Ex, but I tried Tipp-Ex when I started, and I could not get on with it because it's so messy, and I was getting more on my fingers than I was on the beetles. So I tried various pens, and I found Sharpies are really good because they don't affect the beetles in any way, and they don't make them more vulnerable to predation, and they don't come off. So you can put a small mark on, and Sharpies are brilliant because they come in so many colours that you can find a colour that you can see that isn't terribly visible. And the most I think we've caught beetles in the trap are 3 times, and then we've had them up over several weeks. And so really, no, once they may come back a few times, but after that, no, you're fine. So I started this when I started working on, as I say, my absolute favourite, the stag beetle. And the thing about the stag beetle is it's quite a difficult one to do, because there are no obvious aggregation behaviours. People see a lot of stag beetles together when they emerge, and so they'll all emerge together from where they are, and they'll come out, but they don't tend to. And some people have reported seeing them aggregated on sap runs and everything, but if you want them, you can't. But The thing about the stag beetle then is the female produces a chemical that she releases from a region on her front legs, and the larvae incidentally produce the same compound, which is how the males find the females, because the males emerge first and then the females will bring the males to where they are as they're still underground, because that volatile is being given off from the wood as it evaporates that's being produced by the larvae. I was very disappointed that we couldn't find a really good pheromone for these, although we have had some success, and I'll talk about that later. And one of the reasons I was so disappointed that we didn't find a compound to monitor stag beetles is that the males fly in circular paths. So although there have been an awful lot of surveys run to monitor stag beetles, it worries me sometimes that people either see 10 beetles or one very busy one keep going round in circles, because they go in a circular path, the males. And I'm worried that it artificially inflates numbers of the beetles and people think they've seen far more. In fact, they haven't seen as many as they thought. The next beetle that I was lucky enough to be involved in the monitoring of was the rusty red click beetle, or I would call it a later Ferruginous, but I never did Latin. And this is a beautiful beetle. It's tomato sauce red. It's about 2 centimeters long. And in this country, before we started monitoring it, there were no adults recorded on the NBN gateway, and the numbers were in tens. But I was lucky enough to be asked by a couple of Swedish researchers, Mattias Larsson and Glenn Svensson, who had developed a pheromone from taking glands, and asked me to trial it in this country to see if it would work to monitor the beetle. So I started in Windsor, and we put out the pheromones in the traps, and it worked. And we went this pheromone was amazing. Those of you on the call that have used this pheromone will know it is so good that if you have the pheromone, and sometimes I would park in the car and I'd put the pheromone in the rubber seal on my car window in its vial, and it's so good that if the beetle is there within 10 minutes, you'll have them. When I've been down to Windsor Great Park and had people with me, and if you've got the pheromone in the back of your car and you open the boot, the beetles will come flocking in. It was amazing to see so many beetles coming so quickly, from something that we'd never seen to seeing so many of them. Whilst I was doing this, though, I had the traps out, and I suppose I'm a bit of a pessimist and I have a rather cautious nature. So I decided that I wouldn't just put out, in each area that I tried, I wouldn't just put out one trap. I'd put out 2 lured traps and a control with nothing in it to make sure they wouldn't go just in an empty trap. But from my point, it was a very lucky mistake, because, well, a very lucky design. When I put them out, I found out that when you've got beetles in the trap, so we have this triangle design where we have 2 lured traps and 1 empty trap, you wouldn't get beetles in both lured traps. You may get 1 or 2 in one lured trap, but in the other trap, you could get up to 50 beetles. And this kept happening. So we kept finding that in one of our traps would be virtually empty, and one of them have a lot. So that made me think, well, maybe there was something else going on. So we went back to the lab and we did our air entrainment on them. And we tried again, and we looked for compounds, and we found 2 compounds that seemed to act as an aggregation pheromone, but only for males. You can sex these by the length of the antennae and by various other features. And when we were looking, that definitely we got 1 or 2 females, but up to maybe 50 males in a trap overnight. And these 2 compounds added to the compound that was developed by Larsson and Svensson meant that we could improve this scheme even further, because now in areas where people only caught 1 or 2, we could trial it again and see if the numbers would go up, because this extra attraction. And yes, it does. So it's a really good system it was improving what was already an excellent pheromone. My last one that I've worked on, and probably again on the adults, one of my proudest ones, because we actually found the pheromone ourselves, was the noble chafer, the Norimus nobilis, found in this country mainly in traditional orchards in veteran fruit trees. And it was found, seen mainly by mistake. It's found nectarine on hogweed, and it's found up in Worcestershire and Gloucestershire and a few other counties, and in the New Forest. And the unusual thing is that in the New Forest, it's found associated with deciduous trees rather than veteran fruit trees. The problem with this one is it's mistaken for the rose chafer, and the rose chafer's got this beautiful colour again, this beautiful iridescent green colour. But when you find those, you'll find the larvae in compost heaps, and you'll find hundreds of them. So people often think, oh yeah, that's not a problem, we've got noble chafers. No, you've got rose chafers, which are equally beautiful, but not quite as rare. And so we set about trying to find the beetles. We found some. I was very lucky, I found some beetles. And when we did we did the above, we collected these volatiles and we identified the compound and tried it in the field. It seemed to work. We then managed to, I was working with a researcher in Poland. It's more common in Poland. He got me some beetles. We tried again and we got the lure and we put it out and it works. Now, I tried it down in the New Forest and I tried it again in Worcestershire, and it brings in the beetles again really quickly. It's not as good as the pheromone for the rusty red click, but it works very nicely. And this then has enabled us to find a pheromone to work out numbers, these population sizes of these in a small way in both the New Forest, but also to work out that they don't only live in veteran orchards. We found them commonly in outside of orchards as we found them inside. So that's the adults. But one of the things that's really troubled me right the way through from when I started was that if you monitor the adults, and I'll talk again a bit later about the things that you can find out from monitoring the adults, but one of the things that really worried me was that if you monitor the adults and then they disappear, there are no more left. The only way then it's too late because they've all gone. You've lost them all. And so the only way you can find a better idea of how these species are faring is to monitor the larvae. Again, I wanted to do this as non-invasively as I could. And this led to another set of problems. So starting with the stag beetle, which I started the research on, the problem here, of course, is that they're, apart from the fact they're in people's gardens, is that they're underground. And so most people find stag beetles when they're digging in their gardens and they dig up a stump and there's the stag beetle larvae and there's one with a fork through it. And you've destroyed the habitat and you've destroyed the, you've killed some species. Even if you put the wood back in and you put the larvae back in with it, you'll still have killed some and you'll still have destroyed the habitat. Within the tree cavities, we have other problems. So for the, I've never managed to find any of the rusty red click larvae, so I haven't had any luck with that at all, but that's something I'd like to work on at some stage. But with the noble chafers, they are then in the in these cavities in veteran fruit trees. And if you're unlucky, the cavity is so small that you can't get your finger in it. But if it's really big, it's the same problem again then. So you have to put your hand into this cavity and rootle around and find the larvae and get the larvae. And again, of course, although all of these larvae are hardier than you might think they would be, you're completely messing up the habitat. So I wanted to find something that you could do this with, that you could find out were the larvae there without touching a fork or poking your hand into a tree hole. So using another technique, we decided we could use passive diffusers. Now, these are brilliant because it looks a bit like they're only very small. So that the blue and white tube is you put the silver thing, which is filled with carbon mesh, into a tree hole, and the blue and white thing that to me always looks a bit like a balloon pump is about 8 centimeters long and about 1 centimeter wide. So it will go into quite a small hole, and you can put it inside a tree hole and you leave it there for a couple of weeks, 2 or 3 weeks, and you can then take it out, you wash that through, and you do gas chromatography, mass spectrometry, and you'll get a printout, something like this. And this actually is the one from the noble chafer larvae. So you can see here whether you've got any larvae in an area by putting these out. I know that first stage has to be finding the larvae. That's the hard bit, finding the larvae and getting those volatiles. But once you've done that bit, then you're able to find out whether the larvae are there without disturbing that habitat at all, because you can push these down into the cavity, leave it there, and I always tie wire around the top of it, pull it out, and you know whether they're there. These things are actually designed to be used for air pollution. And so you can get they're different color diffusers that will allow different volatiles, and they're ideal for volatiles in the larvae. So it was really, really very lucky. For the stag beetles, we used two-pronged attack, and I was lucky enough to work with Dave Chesmore, who's an electronic engineer up in York, and we worked together on two things. We knew the volatiles that the larvae produced because I'd already identified those, but the stag beetles larvae stridulate. And anybody who's seen the stag beetle larvae, they're not the only beetles that stridulate, but the stridulation is where they rub their second and third leg together. And you can see here that they've got, it's a bit like a row of teeth here, and then you've got another row of teeth there, and they make a distinctive noise, which I hope, I'm not sure if you can hear because I've got my sorry, just go back up. I want you to be able to hear this. Oh, you still can't. So that noise is the stridulation of the larvae, and as I say, they rub the parts of their legs, the plectrum, and together and make these distinct sounds. These distinct sounds then happen, luckily for us, at the same time as they produce pheromones. So if you see on here, on this slide at the bottom, you see the hairs, and by the sides of the hairs, there are very small pores. So they're giving pheromones out, and as they do this, and then they're distributing as they rub the legs together to make that noise. So with Dave and I worked on a system. He devised a system where we could also put little recorders down under the ground, and coupled with the radiellos, the passive diffusers, and that we were sure we would be able to find the stag beetles without touching the fork. The worst thing about it is that stag beetles are not very cooperative on that. They don't stridulate a lot. They stridulate when they come close together, and they stridulate when they are on their own. They've got this rather weird two ways of doing it. So say if they're on their own, they'll stridulate, but also if they move apart from other, they'll stridulate, and then they release this pheromone. But nevertheless, this was another way of recording them. The radiellos I was just telling you about, we've used them in Germany. I've used them across London. I've used them in Richmond Park. And we are able to identify a definite signal that are given off by larvae to monitor the larvae under the ground. And you can find out whether or not the larvae are there just by putting these down and then washing them through. So one of the questions that I get asked from people when I'm doing this is how safe are the lures? And the answer is very safe, because you tend to have microliters of lure, so chemical that's so small that you'd have more problem actually if you swallowed the container than you would if you swallowed the lure. But one of the problems I had with this, some of you may have seen this about stag beetles and ginger. And because stag beetles are found in gardens, when I started my research and I found that the compounds that the larvae gave off, I was looking for other sources of them, and I found they were in ginger and in mango. So we've actually used both ginger and mango in traps, the best lure for a male stag beetle is a female stag beetle, but nevertheless, fresh mango can be successful. But as I said at the beginning, with the adult beetles, that they don't really aggregate. So you're still very lucky. It's not the best method to monitor stag beetles trapping by any means. So moving forward, there's a couple of questions that I ask myself, and that is larval frass. Does it really mean beetles are present? And my answer to that would be a resounding no. More than a Kit Kat wrapper tells you there are people there. All it tells you is people have been there, but not they're still there. And so I started to think about the frass, because the larval frass for the noble chafer can last a few years. It takes quite a while to decompose. And I was worried that as this frass is in the trees, it may give people a false indication of how many. Oh yeah, there's frass there, so we've still got the larvae. And it's a scheme that's definitely used to monitor orchards to see whether larvae are present. But as I say, that the problem is that maybe they were, but maybe they're not still there. So I'm working at the moment on a system to see how long volatiles that are found within that frass last. These are both volatiles that are produced by fresh frass and volatiles that are produced by larvae that get into the frass. And so we can see that there is a decline over time. If you put the larvae back, they pop up, the volatiles pop up again and they go, which allows you to make sure that your orchard is as good as you think it is, because there's no good preserving trees for beetles that when the beetles have long gone. Adult monitoring to me is brilliant, as I said, with the problem that if they go, then unless you've monitored the larvae, you don't know whether the population is still there. But it's allowed us to work out quite a few things, like the sexual behavior of the beetles and how far they can fly, give us a quick indication of population sizes in an area. It's been quite a successful scheme to do it. But is that enough? No, definitely not. No, it's definitely not enough. And one of the things that I have also looked at is heat tolerance of species that are living in trees. And one of the things, as I said, that worries me is that you may have frass in an orchard and think we're fine, we've got them there, they're there. But what you might have is trees that are now getting to a stage that are just too unstable temperature-wise to support a population. And so you feel like it's all right, but it's not. So I've been looking at monitoring temperature in trees and tolerance of larvae to both hot and cold temperatures to see if you can work out whether all trees should be kept, certain trees, even though they look ideal, they're not, and whether you can make them more ideal by covering them with maybe, I don't know, plastic or something to keep those trees viable for longer. So what's up next? Well, I started talking about the violet click beetle. This would be my absolute dream. The violet click beetle, I have only seen the most I've seen of those have been 7, but I was very lucky to get some sent to me last year from a researcher in France. And we've now collected a chemical that's given off by the adults and given off by the larvae that I'll be using to monitor. So my plea now is that anybody who would like to join me to monitor this, I would really, really like to hear from you. This beetle, I feel, is only found in 2, maybe 3 sites in the UK. It's similarly rare across the rest of Europe. And I'm sure it just can't be. I'm sure that if it really was that rare, it would have by now died out. So I'm hoping that this is going to be another rusty red click moment, and we're going to get a pheromone lure that we put out, and we find that in a few years' time, people are going, there's no need to worry about that. It's so common. The fact that we could all manage to miss a large red beetle that was tomato sauce red and 2 centimeters long convinces me that it's far easier to miss one that is about half the size and a very dull color. And so I'm really, really hoping that we will manage to do something with that this summer. But also now I'm beginning to spread my range of pheromones to other insects, for example, Lepidoptera, and I'm hoping to develop schemes to monitor endangered species of moth by enhancing captures in light box traps with pheromones added to bring them in. But yeah, I suppose it's a case of watch this space and please join me to help me. And yeah, that's me. That's all I have to say. Thank you very much for listening, and I hope that you found my talk interesting, and I'm very willing to answer any questions that you have.